Great. Okay, so let's suppose we create a hash function that returns 0. So what distribution do you expect we'll get? All in 0. So let's go do it. Make sure that that's true. This time we don't need to print out the address. It's not useful to us anymore. So we go to colored number, and we're going to go to hash code, and we're going to say override public and hash code return 0. If I delete override, actually, I'm just going to run it real quick. So we run it, and we get 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is just a linked list. Not so great. If I delete override, what do you think will happen? Let's see what happens. It's the same. Just a reminder, boring Java topic from way back, lecture 10, 11. You don't have to say override to override. It's just there as a reminder. And the reason it's there is, let's say you say override and you do public int hash like code, all lowercase or something. It'll warn you and say, oh, hey, dude, you forgot to say capital C. So anyway, that's why we do override, catching typos. Okay, so that's the hash function that gives me back all the items in one bucket. And let's close all these things, buy those things. Okay, there we go. So we get all zeros. Any questions about that? Okay. Here's kind of a, I don't know, interesting question. So what hash function results in this distribution if we wanted to do this? So this right here is the one you want, right? The one you expected. How would I get this? I'll give you guys 30 seconds. It's actually a very simple answer. Almost too simple that it's confusing because it's so simple. Okay, what do you think? What do I need to do here? Num mod 6. I mean, you could, but it's not really your job to do the modding, right? So the class itself, it doesn't know what M is. It doesn't even know that's in a hash table. It should actually just be num. Yeah, so it's one of those things that's so simple, it's confusing. I'm going to run this code real quick. Oops, here we go. So if I do that, it works just fine. The modding is happening in the hash table. Okay. Yeah. So if we go back to that picture real quick, let me just fully convince you with this diagram. The hash function takes the data and turns it into a hash code, which then gets modded. So if the number is, say, 19, I want the hash code to just be 19, and then that gets modded. Okay. It's kind of, when I was in calculus, I remember this problem very vividly from my high school calculus class. It said, what is the limit of 4 as x goes to infinity? It's like, and the answer is 4. It's one of those kind of things. It's like so simple, it's confusing. So the hash code in this case is just num. Return the number itself. Okay. Okay, so return num. Okay. We could do some other things like make up other hash functions. Like that one's the best. But just for the sake of it, we could also try like leading digits or sum of the digits or the length of the number. What? Like, which one do you want to try? Well, we'll do color in a minute. Leading digit. Okay. How do we write a function that gets us the leading digit of an integer? There's a few ways we could do it. What's the laziest way? No, even lazier. You're thinking too much. Nope, not super. No, well, you could make it a string and get the front character. That's the fastest way. The even lazier way is to, of course, consult Stack Overflow or ChatGPT. So let's go try it. Okay. Write a Java function that returns the top digit of an integer. Okay, here we go. Okay, let's just see. Okay, let's see if it works. We don't know if it'll work, but we're gonna try. Okay. Oh, by the way, this other stuff, I was doing an experiment. I'm on Line. Anybody ever use the Line app? No? Okay. So I use Line occasionally because I have a friend in Taiwan and I get a lot of scam messages. And so I set up a thing in ChatGPT where I said like, person A is the scammer and person B is trying to like trick the scammer and whatever. And so if you saw any Chinese there, that was me talking to a scammer with ChatGPT just to see what would happen. An experiment. Anyway, all right. So let's see. I don't know if this function is going to work. It might ChatGPT is not always right, but let's see what happens. Let's do return, get top digit, num. Okay. So we live in the year 2023, and so this tool exists, and sometimes it's good. Okay, so is it working? Yeah, it looks like it worked fine. So thank you, ChatGPT. So I bring this up because this may not, what's that? Oh yeah. Yeah, it even worked for 0. Actually, by the way, when I tried this at home, it worked except for 0, and I said, try again. And it was like, here it is again, but now it works for 0, which is cool. So be aware that this is a tool that you may use in your own projects. But the thing is, it's hallucinating weird answers. They may or may not be right. So unit testing ChatGPT code, I think it will be a real skill. I'm exploring maybe the idea of on project 3, letting you guys use ChatGPT in some limited manner. We'll see. But actually, I heard a funny story today, by the way. Is anybody here in EE 120? Oh, yeah, nice. So a number of two students did the homework, and they, instead of using the correct transform for the class, which might be a Laplace transform, I don't even know, a Fourier transform, they used something called the Z transform instead. And they were like, why are people using the Z transform? Where did they even get the idea? So they sure enough went to ChatGPT, and ChatGPT solved it using a Z transform. And they're like, aha. So anyway, so the point being, the way that you should think of ChatGPT are similar tools. They're very in their infancy now, but they're real. They're in our syllabus because we know that they're useful. It really is a real tool. But I think one of the things you have to learn in your careers is how to use this judiciously. So this is an example of a case where maybe this is fine. I'll say that this particular implementation is a little inefficient, but I don't know, it's clear. So it goes. All right. That's my ChatGPT demo. Which hash function do you like better, though? Num or decimal? Num. All right. So this is just a silly example. The point being, you can make up any hash function you want. You'll get different distributions of items. Okay. Any questions? Yeah.
Hash table is supposed to be random anyway. Like,
right.
Does it really matter?
Right. So why are we even bothering to write hash functions if we want it to be random? We'll get there. This is a very good question. Yeah.